Hello everyone, I am Dr. Sirajul Hafesi. I welcome you in my YouTube channel. Today in this video, I am going to talk about benzene and aromatic compound. Benzene is the simplest aromatic hydrocarbons. The resonance description of benzene consists of two equivalent Lewis structure and each with three double bonds that alternate with three single bond. The true structure of benzene is a resonance hybrid of the two Lewis structure with the dashed line of the hybrid indicating the position of the pi bond. Look at here these two structure and shifting of bond from one position to another positions. The hybrid, the electron in the pi bonds are delocalized around the ring because each pi bond has two molecules, two electrons. So benzene has 6 pi electrons. Some texts draw benzene as a hexagon with an inner circle. You can see the circle represents the 6 pi electrons distributed over the 6 atoms of the ring. Now in benzene, the actual bond length 1.39 angstrom is intermediate between the carbon-carbon single bond and carbon-carbon double bond. Look at here 1.53, 1.34 angstrom and in benzene 1.39 angstrom. The CC bond in benzene are equal and intermediate in length. Now, benzene aplanar molecules, look at here the angles 120 degree and sp2 hybridized and look at the p orbitals. Now, nomenclature of benzene derivatives. The name benzene ring with one substituents, name the substituents and add the word benzene. Ethyl, add the word benzene. Tert-butyl benzene, chlorobenzene. Many substituted benzene have common names which you must also learn. Toluene, phenol, aniline. There are three different ways that two groups can be attached to a benzene ring. So a prefix ortho, meta and para can be used to designate the relative position of the two substituents. 1,2 disubstituted benzene, orthoisomers, 1,3 disubstituted benzene, meta, and 1,4 disubstituted benzene, para. Now, my friends, the two groups on the benzene ring are different alphabetized the name of the substituent preceding the word benzene. If one substituent is part of a common root, name the molecules as derivative of that monosubstitute benzene. You can see orthobromochlorobenzene and nitro groups here, metafluoronitrobenzenes. Use a common root name toluene and phenol, para-bromotoluene and orthonitrophenol. A benzene substituent is called phenyl group and it can be abbreviated in a structure as pH. So phenyl C6H5- or pH. A phenyl group is formed by the removing one hydrogen from benzene. Therefore, benzene can be represented as PHH or phenol would be PHOH. You can see here. The benzyl groups, another common substituent that contains benzene ring, differ from a phenyl groups. So, an extra CH2 group, you can see benzyl and phenyl. Stability of benzene. Consider heat of the hydrogenation of cyclohexene, 1,3-cyclohexadiene, and benzene, all of which gives cyclohexane when treated with the excess hydrogen in the presence of metal catalyst. You can see delage not observed kilocalorie per mole and predicted kilocalorie per mole. So cyclohexane and 1,3-cyclohexadiene and benzene. So slightly more stable than two isolated double bonds. You can see small differences. and much more stable than three isolated double bonds. Minus 85, large differences. So the low heat of hydrogenation of benzene means that hydrogen benzene is especially stable, and this usually stability is characteristic of aromatic compound. Benzene unusual behavior is not limited to hydrogenation. Benzene does not undergo addition reaction. Benzene does not react with Br2 to yield addition products. So addition does not occur, substitution occurs. Now the criteria for aromaticity, Haeckel's rule. Four structural criteria must be satisfied for a compound to be aromatic. A molecules must be cyclic. Cyclic compound, you can see the benzene. Every p orbital overlaps with the two neighboring p orbitals. Cyclic compounds no overlap. 1,3,5 hexatriene. They can no overlap between the p orbitals on the two terminal carbons. To be aromatic, each p orbital must overlap with the p orbitals on the adjacent atom. So to be aromatic, each p orbital must overlap with the p orbital on adjacent atom. Now, a molecule must be planar. Benzene, a planar molecule. Look at here the bond angles 120 and sp2 hybridized and p orbital you can see. Now, a molecule must be completely conjugated. Aromatic compound must have a p orbital on every atoms. So, a completely conjugated rings, you can see benzene, a p orbital on every carbon aromatic. These rings are not completely conjugated. So 1,3-cyclohexadiene not aromatic, 1,3,5 cycloheptatriene not aromatic, no p orbitals. So a molecules must satisfy Haeckel's rules and contains a particular number of electrons. You can see the Haeckel's rule. An aromatic compound must contain 4n plus 2 pi electrons in integers numbers 0, 1, 2 and so on. Benzene is aromatic and especially stable because it contains 6 pi electrons. Cyclobutadiene is not non-aromatic and especially unstable because it consists 4 pi electrons. So benzene and cyclobutadiene, see the differences between. Now note that Haeckel's rule refers to the number of pi electrons, not the number of atoms in a particular ring. So number of pi electrons that satisfy Haeckel's rule 4n plus 2, 2, 6, 10, or 14, 18, like that. So example aromatic ring, completely conjugated ring larger than benzene are also aromatic if they are planar and have 4n plus 2 pi electrons. Hydrocarbons containing a single ring with alternate double bonds, single bonds are called enolines. The name and enolines indicate the number of atoms in the ring in brackets and add the word enolines. 14 enolines, 4n plus 2, 4 into 3 plus 2, 14 pi electrons aromatic, 18 enolines aromatic. Now, although the resonance 5 resonating structure can also be drawn for the cyclopentadienyl cation and radicals, only the cyclopentadienyl anion has 6 pi electron, a number that satisfied Haeckel's rules. So aromatic, anti-aromatic, non-aromatic. Indicate which of the following are aromatic and non-aromatic. Do yourself. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.